Hello everyone. So this is experiment number 10 of the digital lab experiments, which is the VHDL program for half adder. So first let's look into the objective of our experiment here. So here our objective is to understand the function and operation of a half adder and to learn the modeling styles of half adder in VHDL and finally to synthesize and simulate half adder. So first let's look into what a half adder is. So half adder is nothing but a combinational circuit that adds two 1-bit numbers. So one of the 2 bits is the carry from the lower stage or a hardwired high or low bit. So here we have the symbol of the half adder and we could see that our inputs are A and B and our outputs are sum and carry. So when both our inputs are 0, our sum and carry are 0. When one of the inputs is 1, our sum is 1, and when both the inputs are 1, our sum is 0 and our carry is 1. So the logic equation for the sum output is a dash dot b plus a dot b dash, and the logic equation for the carry output is a dot b. So now let's take a look at the modeling styles. The first one is the data flow or concurrent modeling. So here we have the VHDL code for synthesizing a half adder using the data flow or concurrent modeling. So first we include our library, which is IEEE, and then we use our package, standard logic package, IEEE.standard logic package, and then what we do is declare our entity, which is half adder in our case here. The port and the brackets is the syntax of the VHDL code. So A and B here are the input and the sum and carry are the output, as we saw before. So within that, our entity of the half adder gets over. Next we move on to the architecture data flow of the half adder, where we declare that sum is equal to when less than or less than or equal to A XOR B, and carry is less than or equal to A and B, and we end the data flow. So that's the VHDL code for synthesizing a half adder using data flow or concurrent modeling. Next we move on to the next type of modeling, which is behavioral modeling. So here once again we declare our package, and then we start with the entity half adder. So here once again our inputs are A and B and our outputs are sum and carry, and then we end the entity using the syntax end half adder. Next we move on to the architecture of the half adder, where we use a group of conditional statements. So the first conditional statement is if A divided by or equal to B, then sum is less than or equal to 1 and carry is less than or equal to 0. So else if A is equal to 1 and B is equal to 1, then our sum would be less than or equal to 0 and our carry would be less than or equal to 1. And finally, when both of these are false, so that's when the code moves on to the final else part. So at that case, the sum is less than or equal to 0 and the carry is less than or equal to 0. And then we end the process there using the end if, end process, and end behave, which is the syntax for the VHDL code. So that's called behavioral modeling. Next move on to the final modeling type, which is the structural modeling. So once again here we declare our entity half adder, which is the usual thing. We declare the inputs, standard logic inputs A and B, and the standard logic outputs sum and carry, and there we end the entity of the finish the declaration of our entity by using the syntax end half adder. Next we move on to the architecture of the half adder, where we import an AND gate, and we also kind of like declare what our input and output of our AND gate would be. So we have considered A and B as our input of the AND gate and F as the output of our AND gate, and there we end our component. Next we also include another component. So our component here is an XOR gate. So here we add we include the A and B as our input and F as our output. So we use the end component syntax to finish that. So finally we are mapping those two components using this syntax. G1 is colon XOR gate port map, where A comma B are input and sum is the output. And similarly we are once again mapping G2 colon AND gate port map, where A and B are our inputs and carries our output. And finally we end with the code with end half adder syntax. Thank you.